Welcome to this video where I show you how you can use the new CDI extension of MicroStream in combination with the Helidon runtime to create your microservice that accesses your data in memory and stores it through the persistence engine of MicroSystem to the disk, for instance. The CDI extension is a new feature of version 7.0, and it allows you easier creation of the embedded storage manager. So you can configure it through the MicroProfile config properties, but you can also automatically save your object graph when a method has changed some data in memory. You can also put them automatically to the storage. The extension is designed to work with MicroProfile runtimes, so Helidon is there one of the examples where it is working perfectly. Helidon itself is a cloud-native open source set of Java libraries that can be used to create your microservices, and they are powered by NetBeam, so that's the engine underneath. And the MP is the full MicroProfile support, so you have support for all specification of MicroProfile, and so also the configuration one that we use in the CDI extension, and then of course CDI itself. If you want to know more about the project itself, Helidon, then look at their website, helidon.io. In the example, which is also available on the GitHub repo of MicroStream, you will see how you can convert a simple application with the help of that CDI extension to store data very easily and rapidly. For our example, we will use a Maven-based project, and you can create easily such a project for Helidon in two ways. The first way is using the starter of MicroProfile, where you simply specify a few parameters, like it is for Helidon that we are going to create an application. It chooses automatically the latest version supported by Helidon. Also, version of the JDK is 11, and we will generate an example here of the config. Not that it is needed for the example that we will create here, but then all the information is already created with a example of the MicroProfile config property file. And then we can just click on the download, and it downloads a zip file for us which contains the Maven project. The second option to create that example project is to make use of the Helidon CLI tool that can help you in creating a project, but also running your project on the Helidon runtime itself. So I'm going to launch the command Helidon init. Is checking for the latest version, and that seems to be 2.5. And I'm going for the MP version and the MicroProfile version, as we need that for the CDI extension. And I'm just taking the bare minimal project to start from scratch. I need to make a few changes, but that's later on. You will see that later on when I open the project in the IDE. I'm going to define the name of the project, so CDI extension example. The group ID is the one.microstream Helidon demo, and the artifact ID I'm going to use the same one as the group ID. Version is okay, and I'm going to leave the package name also. You can also change that, of course. I'm not going to start the development loop because I'm first going to open the project in the IDE. So now that I have opened the project in the IDE, I can see that it has added some dependencies from Helidon for MicroProfile, etc. As it is only that bare minimum, we are lacking, for example, the JSON binding dependency that I need in my example, so that the payload of the JSON that I send to the REST endpoint is converted to a Java object. So for that reason, I am going to change here this dependency of Helidon, so not only core but taking everything, and then I don't need the metrics, the health, and the specific JSON P1, because they are all included here in that MicroProfile one. The next thing that I do is add the dependency for MicroStream. So we have the MicroStream integration CDI artifact for that. The version here is the final version of version 7, which is released recently. And that is all that we need for our dependency of our example. So let us walk through the example, and the idea is that we have an endpoint or several endpoints where we can maintain a list of products. And the idea is that we store those products in memory, so no database, and that later on we just add the MicroStream functionality to it so that the object graph with all the products in it is stored to disk, so that we do not lose our information when we start the Helidon runtime again. So we just have a standard EXRS endpoint, a product controller, where we consume and produce JSON. And we have several endpoints, for example, a get endpoint to retrieve all the products. We have here a post endpoint to store a product, and we can also delete a product. And the functionality of handling the product is done by a repository or a service, if you want to use that name, where we, in case of the get all products, we just return all the products here from the inventory. And the inventory is where we actually store the data. We can save a product, we can find a product by ID and delete one, etc. The product itself is a very simple one, just an identification, a name, a description, and some rating. And then here the inventory, these are like our data warehouse, if you like, where we store everything. We store a set of products, and we have here again methods to add them and retrieve all the products that we have there. For those who know MicroStream already a bit, then you know that you need to indicate the first object, the first object of your object graph that you want to store to disk, and then all the dependent objects in memory, like this set of products, are stored together with that inventory. So now with that CDI extension that we have added to the project, we can just indicate that our root is here, this inventory, and we can indicate that by the storage annotation. From that moment on, the system knows that this is a root, and when we read or write the information, then it is always starting from this root class. But with that CDI extension, we can also do another optimization so that we don't need to access, for instance, the embedded storage manager ourselves and store and save the changed products manually with the statement. We can do that more or less automatically, like some kind of transactions, although of course transactions are not really supported with MicroStream. They work on different concepts. But here in our controller, we call that product repository, for instance, and every time we have saved a new product, then we need to make sure that the data is stored to disk again so that we don't lose any information. So then we can indicate that requirement by putting the store annotation here. So every time this method is ended, so after the last statement, the return here, then all the collections within our root object, so in our case the set of products, are stored to disk. The same we should do for the delete, of course. Reading is done automatically through that storage annotation. Whenever we access that inventory, the data are then retrieved again from disk if needed. With the addition of that store and storage annotation, our application is actually already ready to be executed by the runtime. You can also configure, of course, the embedded data storage manager, where are the files located with all the content of the objects that make up that root object. And probably most people then will, of course, indicate where that directory is located. That is a property that you can define with here the storage.directory MicroProfile key. There is a default, but now with assigning it an explicit value, then of course then we can put it on a precise location. These are all the default configuration parameters that are described in our documentation, and you just have to prepend them with one.microstream so that we are sure that we do not clash with any kind of other configuration properties that might be available in your environment. We just do a Maven clean package because we have a Maven project here, and it generates the executable Java file, including our Helidon runtime and application and the MicroStream dependencies for running. So the jar file is now ready, and we can start it up with the Java -jar option of Java and the CDI example jar file, and our application is ready to be tested. So we can try the application by submitting a few curl commands, by executing a few curl commands. So the first one, we can save a product in our database. We submit a post request to that endpoint that we have defined, and we define here the JSON data with, for example, here that we submit the banana as a product. The database is started. You see that there was an additional entry here that it used that storage directory information from the config, and we get the confirmation that it is added to the system. We can check if it's available there with the curl command to get all the products, and then we see indeed that there is a first product available. We can, of course, quickly update and create a second one with a second fruit. And if we then request them all, then we see indeed that we have now 2 products there. We can stop the runtime here. There is no problem because everything is saved. And if we look at that demo project directory that we specified in the configuration, we see here that there are a few files which makes up all the information that is needed to restore all the information into memory again. And let's see if he picks up the data as it should do. So we start up Helidon again, and we retrieve the products, and then we see that we still have those 2 products which we have stored in the previous run of the example. So this is the end of our little demo. And then you have seen that with that CDI extension, which can be used with any MicroProfile runtime, I gave the example with Helidon, that you can see how easy it is to convert, to adapt your application to make use of MicroStream, and then make sure that your data are stored and available again when you start up. Just add the storage annotation to indicate the root object, and then with the add store annotation, which is actually a CDI interceptor, you can make sure that any changes that you have made are saved to disk so that they are not lost the next time. Thank you for watching, and see you later. Bye.